question. Anyone can answer. What is children? We are doing magnetism questions, electromagnetism. I will be asking questions. If you know, you tell, or else I will tell children. The magnetic force on magnetic proton acts towards north in a horizontal plane. Children, magnetic force is acting towards north. Force is acting towards north in a horizontal. If proton is moving vertically upward, means current is upward. Proton means positive charge. Positive charge direction only is taken as a current. Okay. What is the direction of magnetic field? Which rule will use, children?
Left
That
hand
means
side.
left hand good.
Can you use and tell me what is the answer?
Sir, east, sir.
Answer is east.
Onward, on our right, magnetic.
Okay, let me check. So, children, this is.
I'm thinking west, sir.
1 second, let me check. So, children, force is acting towards north, he's saying, children. Force is acting towards. So this is my guess. Okay, children. Okay, force is north. Your front is north, no? You put your thumb like this, children. Your front is north. Your front is north. Your front is north. And current is upward. Current is upward. See, children, current is upward. Okay, and this is towards the right side. Right is east, children. Right is east. Right is east. Okay, so magnetic field is acting in east or right. Anything is okay. Write down both answers so that.
Sir, thumb finger will be on left side, no, sir.
Huh? How no, left side? North, no. North means your front, no. North means your front. Your front side. Your front is north. Your back is south. A charged particle move in anti-clockwise direction. Children, see here. A charged particle is moving in anti-clockwise direction. A charged particle is moving in anti-clockwise direction in a magnetic field which is perpendicular to plane of paper directed downwards. Magnetic field. Children, magnetic field is acting which is perpendicular to plane of paper downwards. Children, if this is a paper, magnetic field is going inside, children. Magnetic field is going inside, children. Inside. Do you understand, children? Magnetic field is inside. You are sitting on doing no, children. You are sitting and doing no. That's why they have given question like this. Okay. What is the nature of charged particle? What is the nature of the charged particle? So, children, magnetic field is inside, children. Magnetic field is going like this, children. So you have to use which rule, children? Right hand or left hand? Right hand thumb rule.
Right hand thumb rule.
So magnetic field is going inside, children. Magnetic field is going inside. So magnetic field is going inside. When magnetic field is going inside, children, see here. 1 second, children. So magnetic field is going inside. If I keep, because I said magnetic field is going inside. So when magnetic field is going inside, my thumb is coming right side. My thumb is coming right side. Means current is right side. Current is right side means positive charges are moving in clockwise. Clockwise. So this is negative charge. That's it. What is the charge on this? Means negative charge. Why negative? Because current is coming in clockwise, children, for me. Clockwise means current. Current is always strong. Positive charges will take consideration of current. So that would be negative charge like that, children. We should think. Okay, third question. Give an application of electromagnetic induction. Can anyone give an application of electromagnetic induction? Application of electromagnetic induction. Generator. Generators are constructed on electromagnetic induction. Generators. Okay. Suppose a coil is placed in a changing magnetic field and the circuit is not closed. Children, suppose a coil is placed in changing magnetic field. See here. Suppose a circuit is kept in changing magnetic field. Changing magnetic field means north and south, like this. Changing. Magnetic field is coming, going, coming, going, coming, going, coming, going, coming, going. Here, changing magnetic field is occurring. Okay. Suppose here, I kept the switch off. Here I kept plug the key. I kept switch off. Children, will the current flow in this circuit or not? Will the current flow in the circuit or not? This is the question. Suppose a coil is placed in changing magnetic field and circuit is not closed, open. Will the current induce in the coil or not? Children, because
it will come.
It will come, yes, because there is no battery. This plug key will work for battery. There is no battery only, children, here. There is no battery only. Current will come. Current
But
compulsory it will
galvanometer
come. But what is the
should
thing means that current will not be showing in the galvanometer because it is open circuit. No, children, this is open circuit. Galvanometer will not move, but current will come, children. Current will be in this current electromagnetic induction. Current is induced, which cannot be shown in galvanometer because here the plug is open. Galvanometer may not work, but current is coming. Yes. Okay, children. Next, in domestic circuits, which wire we connect to the fuse? Children, we connect the fuse to which wire in domestic circuits? Live wire,
live
neutral
wire.
wire, earth wire. Live
Live.
wire. Always we connect the fuse and switch, both to live wire only. Fuse and switch, both will connect to live wire only. Okay, children, fuse and switch, both will connect to live wire only. Next question. Suppose, okay, give application. Okay, no, which question I'm doing? Okay, 3, 4, 5, sixth question, children. Okay, now sixth question, children. Please see, core of an electromagnet must be of soft iron, not steel. Why, children? Soft iron only we will take. We should not take steel. Why we should
It
not
could
take
become
steel?
permanent magnets.
Yes, steel will become permanent magnet. Steel, if you use, it will become permanent magnet. We don't want permanent magnet. We want what? Electromagnet.
Electromagnet.
We want electromagnet. Steel will become permanent magnet. That's why we will never take a steel. We'll take soft iron because we'll bring electromagnet. What is an electromagnet? Substance which behaves as a magnet only when current is.
Current is passed.
Substance which behaves as a magnet only when current is.
Awesome.
Substance which behaves as a magnet only when current is passed.
True.
Seventh question, children. What happens to the force experienced by current carrying conductor if when placed in a parallel magnetic field? When you place in parallel magnetic field, perpendicular magnetic field. Children, in parallel magnetic field, children, and perpendicular magnetic field is asking. See, children, suppose perpendicular magnetic field is like this, children. Here, force will be maximum, children. Here, force will be maximum because F is equal to BIL sin theta, children. Because sin 90 will be 1 maximum. In perpendicular magnetic field, it is maximum. And in parallel magnetic field, sin 0 is 0. So, force will be 0. Children, in parallel magnetic field, force will be 0. In perpendicular magnetic field, force will be maximum. In parallel magnetic field, force will be 0 because sin theta is 0. Sin 0 is 0, children. Okay. In parallel magnetic field, force is 0. In perpendicular magnetic field, force is maximum. Please try to understand, children. Don't sit like that. Try to understand. Eighth question. With the help of neat diagram, describe how can you generate induced current in the circuit. This one you can. Induced current in the circuit. Induced current in the circuit. How can it? We discussed one single coil experiment, double coil experiment. Okay, push and pull a bar magnet. It will induce the current in the coil by electromagnetic induction. What is electromagnetic induction, children? Relative motion between coil and magnet produces current. 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 Ninth question, children. How many times the current produced in AC generator reverses its direction in one complete rotation? Children, in generator, when coil is rotating once, polarity changes how many times? Polarity changes 2 times, children. Always remember, when coil is rotating 1 time, polarity changes 2 times. How, sir, you may ask. How, sir, means children, you should understand, children, basic concept only. Suppose it is like this. Like this is going, like this going, it is coming like this. This is one rotation. Okay, children. So normally what happens? After half rotation, polarity reverse. After full rotation, polarity again becomes normal. After half rotation, polarity reverse. After full rotation, polarity becomes normal. So what did you understand, children, here? What did you understand? Polarity changes 2 times in one rotation. So polarity changes 2 times in one rotation. What is the frequency, children, we use? Anyone? In our India, 50 hertz. Children, are you able to hear me? Anyone?
Yes, sir.
Yes, sir.
Children, I will explain. We use 50 hertz frequency. 50 hertz frequency I told many times, but no one asked why. What is meant by 50 hertz frequency? 50 hertz frequency means our coil in generator, which is producing 220 volts, it rotates 50 times in 1 second, children. That is meaning. 50 hertz frequency current is coming means what does it mean? The generator inside the coil is moving 50 times in 1 second. One time one rotation two times, no children? One rotation two times. So 50 rotations, how many times polarity changes?
100.
100.
100 times polarity changes. 100 times, children, try to understand. In one rotation, polarity is changing two times. We use 50 hertz current. 50 hertz means what? 50 rotations in 1 second. 50 rotations in 1 second. 50 rotations in 1 second. So how much is polarity changes? 100 times. 10th question. Yeah, no, oh yeah. How many times AC supply in India reverse this direction in 1 second? It's 50 times. Okay, children. Question is how many times AC supply in India are reversed? How many times rotation is 50 times, but polarity changes 100 times. Rotation 50 times, children. Polarity changes 100 times. Polarity is changing 100 times in India. Okay, children. 10th question. Be careful, children. Like this. State the disadvantages of direct current. Direct current cannot be sent to long distances. Direct current cannot be sent to long distances. Direct current cannot be sent to long distances. That is main disadvantage. Direct current cannot be sent to long distances. Why? Because a lot of energy loss will be there. Lot of energy loss will be there. Okay, and also polarity does not change. Polarity, direct current polarity does not change. Polarity does not change. What is the main disadvantage? Means it cannot be sent to long distances. Example is battery or cell. Wherever you put battery, there only will get current. But using battery, we won't put wire and we'll put use no children. No, wherever we put battery, there only will produce current. So why? Because a DC current cannot be sent to long distances because a lot of energy loss will be there if you send to long distances, and all your current gets wasted. Learn the question. List four characteristic features of circuits used in residential buildings. Children, list four characteristic features of circuits used in residential buildings. Four characteristic features of circuits used in residential buildings. Children, we will use parallel circuit. Okay. Number two, in parallel circuit, low power rating circuit will be there, children. Low power rating will be there, which is 5 amperes for bulbs, fans, and high power rating circuits will be there. High power rating circuits will be there, which is 15
15
amperes.
ampere.
Okay, children, and fuse or MCB is used, and mainly earthing is done for full circuit. Earthing is done for full circuit. Earthware is used, which prevents. Okay, so many we can write, children, but these are things which is expecting, children. We will connect in parallel, and low power rating circuit will be there, high power rating circuit will be there, fuse or MCB is connected to the all wires, and earthing is done for all the heavy 15 amperes current. Earthing is done for all 15 amperes rating circuit. Earthing and fuse is kept for high power rating. Earthing and fuse is kept for high power rating. Earthing and fuse is kept for high power rating always. 12th question. State three factors on which magnitude of magnetic field due to a current carrying conductor solenoid. In solenoid, magnetic field depends upon what factors? Anyone?
The current.
Number of coils.
This is the formula, children. Okay. Okay, very good. Number of coils, someone said. Magnetic field depends upon number of turns of coil and current we
Current
are
flowing.
sending and area of cross-sectional area of coil. Cross-sectional area of the coil. These are the factors. B is equal to mu naught NIA. In higher classes, you will study this formula. On what factors solenoid magnetic field depends? Means number of turns. We'll put turns, no children, like this turns. It depends upon number of turns and how much current you are sending and how much big coil you are making. Big coil you are making or small coil you are. It also depends upon area. Okay, so on what factors it depends? Can anyone say? Turns, current, area. On what factors it depends? Anyone?
Turns, current, and area.
Turns, current, and area. On what factors it depends, children? Turns, current, and area. Okay, children, you should remember all those things, children, because as it is in textbook, they are not given, but they will ask children. They expect you to learn all those things. Write one application of right hand thumb rule. Children, right hand thumb rule we used to know the direction of
Current.
magnetic field. Fleming's left hand rule we used to know the direction of force. Fleming's right hand rule we used to know the direction of. Fleming's right hand rule we used to know the direction of
Current.
Current. And one more rule is there. Simply, I'm asking it. They have not asked. Swimming rule is used to know the deflection direction of
magnetic,
deflection of
deflection.
compass. Direction of deflection of compass. Thumb rule is used to know direction of magnetic field. Left hand rule for force. Right hand rule for current. And swimming rule for direction of deflection of the compass. Swimming rule is to know the direction of deflection. State the difference between Fleming's left hand rule and Fleming's right hand rule. Name the devices which these rules are important application. Children, what is the main difference between Fleming's left hand rule and Fleming's right hand rule? Fleming's left hand rule will give
is
force.
used to measure
Force
the
Fleming's
and
right hand rule will give
current,
current. This is used in which instrument, children? Electric motor. This is
motor
used in which
generator.
instrument, children? Electric generator. You have to write in the form of compulsory, like a box. You have to put and you have to write. Differences means box. If you don't write box, no marks, children. Compulsory in box nicely. And if it is possible, please define both the rules also, children. Okay. Next 15th question. State the rule used to determine the direction of magnetic field. Magnetic field,
Right-
direction of
right
magnetic field,
Right
hand
thumb rule. To know the direction of force,
Fleming's
hand rule.
left hand rule,
Fleming's left hand rule.
to know the direction of current.
Fleming's
hand
right hand
Right
rule,
hand.
Fleming's right hand
Again,
rule.
same question. Why this fellow is asking? I also don't know. 16th question. What is short circuiting? Accidental contact of live wire and neutral
Live
wire
wire
is
and
called
neutral wire.
short circuiting. What is short circuiting, children? Anyone? Accidental contact
Accidental
of
contact
contact
of
of
live
live
wire
wire
and
and neutral
neutral
wire is
wire.
called short circuiting.
Short
Accidental contact of live wire and neutral wire is called short circuiting. Live wire and neutral wire, they won't touch each other. If they touch each other, that is called short circuiting. Accidental contact of live wire and neutral wire is called short circuiting. Okay, children. Question is, state one condition which can lead to it if they touch, live wire and neutral wire touch each other. Under what conditions? It may be due to low quality wire, it may be due to some
Water.
insect bite, or it may be due to entry of water. Okay, children. And name a device in which household that acts as a safety measure for it. What will use to
good quality of wire,
no. Safety measure is fuse and earthing. What are the safety measures for short circuiting and overloading? Fuse and earthing. What is the safety measure for short circuiting and overloading? Fuse and earthing. How to avoid it is good quality wires. Okay. State the principle of its working, children. What is the principle of fuse working? Anyone? What is the principle of fuse working?
Prevent overloading of current.
Heating
Where is the-
effects of electric current. Heating effects of electric current. Joule's law of heating. Joule's law of heating of electric current. What is the principle of fuse? Joule's law of heating. What is the principle of fuse? Joule's law of heating. What is the principle of fuse? Joule's law of heating. Joule's law of heating. Should know, children, all these things by now. You are not answering at all. Should know all these things by now. Okay, next question. Distinguish between a bar magnet and solenoid. Can you tell some differences between a bar magnet and solenoid? Bar magnet is a
permanent
permanent
magnet.
magnet. This
Solenoid
is
acts as a magnet when
Acts as an
current is passed.
temporary magnet. Acts as magnet only when current is
Passed.
flowing.
through.
Okay. And here, north and south poles are fixed.
Fixed.
This can be
What?
changed. By
Changed.
how you change? By
Polarity.
reversing the direction of
Polarity.
magnet.
Okay.
And here, strength of magnetic field is fixed.
Fixed.
Here we can change by altering the current, by altering the terms, by altering the area. We can keep on changing. And if it is possible, impress your examiner by drawing a diagram of solenoid and all those things, children. You can draw, I hope. Okay. Please impress your examiner always with the diagrams, children, so that he will understand, yes, you have the knowledge of this subject. 19th question. 19th question was, okay, children, so 19th question, how can a magnetic field be produced without using a magnet? Without using a magnet, can we produce a magnetic field?
Yes, sir.
How?
Double
By
coil
By passing current.
passing current through a conductor.
That's all. A current carrying conductor automatically produces magnetic field, no, children. Without using a magnet means don't get confused. A current carrying conductor produces magnetic field. Current carrying conductor produces magnetic field. Current carrying conductor millions of times I told. Okay, next question. Describe an activity with labeled icon to show that current carrying conductor experiences a force. Children, current carrying conductor experiences force. Do you remember this activity, children?
Electromagnetic
Okay,
activity.
this is magnetic field. Here we will keep a current carrying conductor, and this experiences force. This experiences force. State the rule to determine direction of force. Fleming's
Fleming's left-hand rule.
Left hand rule.
If you write left hand rule, I won't give marks, children. I want Fleming's left hand rule. If you write left hand rule, I won't give. Okay, children. Because if you say right hand rule, what should I think? Right hand thumb rule or Fleming's right hand rule? So use the word, children. Explain the various parts of AC generator. Okay, what are the AC generators? Slip rings will be there, brushes will be there, okay, and armature will be there. Okay, what are the uses of armature? Armature rotates in magnetic field. Armature rotates in the magnetic field. Brushes carries the current. Slip rings alters the polarity. Slip rings alters the polarity. Slip rings alters the polarity. Brushes carries current. Brush armature rotates armature rotates in field. Okay, next question. Last question, children. Mr. Sharma used to park his car in the basement of his house. One day in the morning, he noticed that his basement is full of water and its walls were wet because of the long rain in the night. When he entered the basement, he experienced a major shock. His father, seeing him from outside, rushed to the main switch and switched it off. Thus saved his life. Okay, what precautions Mr. Sharma should have taken to avoid such incidents in future? He did not take one important precaution. That's why so much short circuiting and overloading is occurring in the house. Yes, what is that?
Earthing and fuse.
Yes, earthing. He did not put earthing. If earthing was there, he would have not got short that much. Earthing and also fuse should be used. Earthing and fuse should be used, and he should. Okay, then that much shock would have not come, children. Okay, earthing and fuse should be kept because during short circuiting and overloading, any accident happens, all the current goes into earth, and fuse will stop the current. All the excess current goes into the earth, and fuse will stop the current by blowing off like this, children. These are the precautions you should take to avoid overloading and short circuiting. Okay, children. Anyone have any doubts, children? I completed magnetic field worksheet.